Okay, so chlorine steals an oxygen from ozone, um, but oxygen doesn't like it. So if there's just like a free radical oxygen floating around there, which happens quite often, it's gonna be like, wait, I want that oxygen, and so it'll steal it back. And so then you're left with O2, so oxygen that we breathe, plus another chlorine, which what that means is now it's free to like go and rip up other ozones. Hopefully that makes sense. Why isn't this getting smaller? I don't like it. All right. So that's how the chlorofluorocarbons, the chlorine is the devil. It wants to break up all the oxygens, primarily from ozone, and then it's bad at holding on to its oxygen molecule. Oxygen comes and steals it back, and then it's free to go and grab more oxygens off of ozone. All right, the acronym HCFC refers to hydrochlorofluorocarbon, which is, let me write down this crazy definition. Let's zoom this in. Which is any group of organic compounds that contain carbon, chlorine, fluorine, and hydrogen. It's used in refrigerants and in place of CFCs. HCFCs have a shorter lifespan and are less reactive, or have a less reactive chlorine. All right. So let's move this up so you guys can actually read it. There we go. Nice. All right, identify 3 examples of biotic compounds in an ecosystem and 3 examples of abiotic compounds. All right, so biotic, remember that's living stuff, plants, animals, and let's not forget bacteria. You could have had different things. You could have had more specific examples of plants and animals and stuff. Abiotic. You could have several different. What I had down is soil, water, and let's go with air. Yeah. All right. Complete the following table for these biogeochemical cycles. All right. Let's look at carbon first. Carbon is, I can't read my own handwriting. Building block of 4 major molecules. Yeah. Okay. It's the building block of 4 major, that's a big space, of molecules. We'll shorten it down. Building block of molecules. There we go. The largest reservoir is going to be in rock. Methods of transport are going to be gas, sediments, fossil fuels, Those are just some examples. There's more. And then, is it in our atmosphere long or short? It is, or in the cycle long or short? It definitely is long. All right. Nitrogen, or it takes long to go from one thing to another. It takes a while to go from carbon in the atmosphere into rock. All right. Nitrogen is the key component of proteins, DNA, that kind of stuff. Sorry, this stuff, it's so small. All right. It's found 78% of our atmosphere is nitrogen. So that is the largest place that you might find it. You're going to find it through fixation, or they shorten it. So nitrogen fixation, nitrification, assimilation, ammonification, and denitrification. So if you ever see FNAAD, that's what that is. All right. And this cycle is a lot shorter than the others. All right. It doesn't take long to go from one of these phases to another. All right. Phosphorus is used in in ATP. It's in your teeth. Whoa. And basic, it's gonna help out with your bodily functions. You need phosphorus. All right. This is definitely found primarily in rocks. Okay. And an important thing to remember, there's no atmosphere involved in this. All right. It's in soil, erosion. It's going to be a big part of it. And producers are going to store it. Remember, this is one of those things that if algae gets a hold of it, you're going to have a eutrophication. It's going to be a problem. All right, this is the longest of all of them. If it's in rocks, it's going to take longer to get from one thing to another. The water cycle, it's obviously in living organisms. It's the universal solvent. All right, kind of a big deal. Water is, if you didn't know, kind of a big deal. All right. This is primarily found in salt water, or the place we find water the most is in salt water. All right. You guys know precipitation, runoff, groundwater. You guys know the water cycle. That's how it's transported. And then this is super short again. Doesn't take long for a puddle in your front yard to evaporate. All right, write the balanced equations for photosynthesis in the box on the right. So photosynthesis, this is, again, is equal, or I already went through and made it even. So you need 6 carbon dioxides plus 6, let's do plus 6 waters. I can go back and I can make these better. Plus the sun. It's going to give you sugar, glucose, which is what, 6 C2, nope, C6, C6, H12, whoa, and O6, plus your oxygen. That's six of those though. Alright, let's see. Can go and make these smaller for you guys. Great if you could not get in my way. There we go. That way you know. There we go. I might cut this out then. If I have the time. All right. Cellular respiration. All right, so you're going to have glucose. I'm going to snatch that from up here. Control C. All right. Plus 6 oxygens. And that's going to give us 6CO2. It's pretty much this photosynthesis in reverse. H2O plus energy. Alright. In lieu of time, I'm not going to correct that because, or the little numbers, because you can see you literally just flip it, but it's going to give off energy. Okay. The approximate age of the Earth. We didn't talk about it. It's something good to know. Will you have a question on it on your test? Probably not. So I wouldn't stress too much about like, oh my gosh, I have to memorize this. Like, I wouldn't worry too much about it. So 4.5 billion years. All right, the following species, a zebra mussel, that's going to be an invasive species. C. Galapagos tortoise. All right, is going to be your endemic species, meaning it's not doing too hot. F. This is annoying. American alligator. That's going to be probably a keystone species. They are actually kind of cool in that way. They create little homes because they dig little nests for themselves. Tiger salamander. That's going to be your indicator. Remember, most, if you're not sure, most amphibians are going to be your indicator species because they spend half of their time in water, half of their time in land. A lot of amphibians, they can take in air through their skin, which will affect them. So, all right. Norway rat, that's going to be a generalist. It don't care. Oh, A. It'll eat anything. In fact, not that all rats are generalists, but with this pandemic, so that means giant panda specialist. We've talked about that quite a bit. In New York right now, I guess rats are eating rats because since there's no people out and about, there's no extra food and trash lying around that the rats can eat. So I guess they have seen several cases where rats have been duking it out in New York and eating each other. So that's pretty crazy. All right. Anything you need to know about them? Not really. You do need to know all of these key terms, so just make sure you know them. Go through and review those. Biodiversity. All right. Variety of different species, genes, ecosystems, and functions. All right. Define the term biome. All right. Terrestrial regions inhabited Bye.